Hey everybody.
I'm not sure you can read all that.
Okay. What I figured out, I'm not sure if this is known to everybody else, but what I figured out, the the Pythagorean theorem is that the square of the two two gives a hypotenuse, gives the square of the hypotenuse. So square of the base of the something gives a hypotenuse. Well, anyway, what Pythagoras said was that each integer, a whole number integer, there's no irrational numbers didn't exist. Everything's integers, whole numbers. But um, the diagonal of a square is an irrational, non-repeating, um, uh, non-ending, non-repeating irrational number. The diagonal of a square. If it's one unit this way, one unit this way, it's going to be an irrational, non-repeating, non-ending, irrational number. So there's irrational numbers for the rational numbers that Pythagoras thought of. But if you fractalize a square, divide it into tiny squares, that's all I mean by fractalizing, then it's then you can, if you use different measurements, different unit measurements for the diagonals, the diagonal fractals, each square is a fractal of the whole square, then yeah, you can have a multiple. Two units going down this way, two units going down this way, you'll have an even 2 units, fractal units for the diagonal. So that's a real number. That's a rational number, I mean, rational 2 rather than 1 dot so whatever. And if you fractalize it, it's 3 by 3. The fractal units, there'll be different units than there'll be tiny diagonals, but these tiny diagonals will add up in a different unit measure to be a whole number of fractal units squared. It'd be a rational number is what I mean, rational number. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 2. But if you don't fractalize a square, it would be 1 unit with an irrational number going this way. So I don't know if this is helpful knowledge or anything like that, but if you fractalize, this is what I call fractalizing the square, then you do end up with rational numbers. Rational numbers. Although if you take one square by itself, it would be an irrational number. But you take the squares as a whole, you add them together, they're 2 units, the same as this unit, the same as this unit going across. I should put 2 by 2, 3 by 3, but I didn't. But these are fractal squares. This is just a regular Pythagoras square. So I hope I explained myself clearly, although I went the way all the time. This is rational diagonals of fractal squares. So thanks a lot for watching.